Hey guys, how are you doing today? My name is Pawan Malwal, and today I'm gonna discuss about one of the very common as well as the interesting topic in Apache Spark. That is the difference between RDD data frames and data sets. I find it a little confusing sometimes, and I've also observed that for beginners, it's difficult to understand the difference between these three different types of APIs available in Spark. Okay, so I will try to explain. I've collected different data points from the internet, and I'm gonna just put it in a way I have understood it, and I even try to make it a little more easier for you to understand so that you can remember it. Okay, so yeah, let's get started. So first, we'll just understand the basic definition of RDD data frames and dataset. So RDD is nothing but the resilient distributed data set, and that provides you a read-only partitions of the collection of records, right? So this is the very fundamental data structure provided by Spark. Okay, so when it comes to data frames, APIs or data frames, so it provides us the higher level abstraction. Okay, so like in RDD, we need to get into the lower level and we need to write every logic for our code, but data frame comes as a higher level abstraction where we get some of the inbuilt methods which we can use, like map, reduce, and all that, which we were supposed to write in RDDs, right? And this also, or the data frame also provides you a organized way of putting your data, or it provides a structure of your data, right? So, and it will also have the names to all your columns of your data. So for example, you can consider it as a table in the relational database. Okay, so and the final one is the data set, which is I would say the best of both RDD and data frames. So it kind of provides you or overcomes the limitation of RDD as well as the data frames, and it also provides you much optimized or faster processing when it comes to the latency. So it gives you the lowest latency compared to RDD and data frames, and it's also type safe, and it's an extension of data frame APIs. Okay, so the next thing is we are gonna see the comparison of all three so that it would be clear for you guys, and it would be easy to even understand the difference between it. So what I have done is I have collected different information, and I've tried to put it in a tabular format so it would be easier to compare all the three APIs. Okay, so yeah, let's start it. So first thing is your RDD, data frames and data set. So in this, the first point I mentioned is the Spark releases. Okay, so the RDD was introduced in Spark 1.0, whereas the data frame was introduced in 1.3, and the data set was the latest one, which was introduced in Spark version 1.6. Okay, and the next point is immutability. So when it comes to immutability, all three are immute. So that means once it is created, it cannot be changed, but we can uh, always create the new structure out of it. So in case of RDD, once you create RDD, you cannot change that. It's like immutable. So when you want to change it, you'll have to create a new RDD out of it. So that goes with the data frame as well as data set. Okay, and the third thing is schema. So RDD doesn't come with a schema, and it is used mainly for your unstructured data or for some unstructured logs or stream data. But when it comes to data frame and data set, it comes with the structure of the data, or it gives you the tabular format or the schema attached with it. Okay, and the next is optimization. So RDD doesn't have any inbuilt optimization engine available. So whatever the optimization you're supposed to do, it all depends on the developer who is using the RDD. So that's the reason it also called as the low level API, where most of the logic optimization, even the performance optimization and code optimization, everything is something which developer is supposed to take care. But when it comes to data frame, we get an upper hand compared to the RDD, where it comes with the catalyst optimizer, and catalyst optimizer has four phase of optimizing your code, or so it has four different phases where it first analyzes your logical plan, then it optimizes your logical plan, then it creates a physical plan, and ultimately generates the code, which is the optimized code, right? So but when it comes to the data set, so this is the as I just mentioned, this gives you the best of RDD as well as data frame. So it has like the catalyst optimizer as well, but on top of that it also has the tungsten, which optimizes the code. So tungsten engine execution is something which even optimize your code much better compared to your catalyst optimizer, or the code and even your the ultimate code what you generate, even the data when you kind of shuffle your data, or when you transfer your data over the network, it provides you much compacted form of your data. So data set, that's the reason we get the best optimization from the data set. So next is typed. RDDs are typed ones. So like the RDDs are similar to your other familiar object-oriented programming, where you get the compile time type safety. And when it comes to the data frames, these are not typed. So if you're, suppose in case you create a data frame on top of your structured data, in case like you consider it as a table, and if you're trying to access a column which does not exist in the table, okay, so what happens is during the compile time you won't get those errors, but when you run it, it generates the error. Okay, so that column does not exist, and which is very expensive operation, because when you're running your job on top of maybe terabytes of data, and it's like maybe 1 hour long job. So after 1 hour, or probably after a certain time, you get to know that that column doesn't exist. So that's a limitation with your data frame. But when it comes to data set, it provides you the type safety as well. So at the time of compilation, you get to know if you have any of such error. Okay. Next is memory efficiency. So memory efficiency is not there in RDD, or it is I would say not good in RDD, because the main reason being is like in case of you want to do the shuffle operation, or even if you want to do the caching of your data, what happens is it uses the Java serializer, and the serialization and deserialization of the Java object, it takes a lot of time, and it's not memory efficient at all. When it comes to data frame, this also does the serialization and deserialization, but we have got a cryo serializer, which is I would say the refined form of your Java serializer, and it gives you a much compacted or much optimized bytecode, which is a less costlier operation compared to our Java serializer. Okay, and so these the serialization and deserialization, it's like ultimately it increases your cost, and it also increases your IO. So the compact your data is, what you are transferring over the network, the better performance you get. So when it comes to the data set, it has a new way of serializing or deserializing the data, and it does it using tungsten with the help of encoders, and it make use of the off-heap memory, which also kind of avoids the garbage collection. So overall performance, what we get in the data set is the best compared to the compared to our RDDs and data frames, and that's why they are memory efficient. So data sets are the most memory efficient. The next comes the syntax error. So syntax error, you get to know, like if there is any syntactical error in your code, you get to know during the compile time in all three, which is RDD, data frame, and data set. But when it comes to analysis error, error I just mentioned, that if you are trying to access a column which doesn't exist in the table, or your schema, you get the compile time error in case of RDD and in case of data set. But in case of data frame, you don't get analysis error during the compile time. That is something you get to know at the runtime. Okay, so the next thing is the level is nothing but the APIs, the level of APIs we have got in RDD, which is the very low level API. So most of the operations, or the kind of the logic we want to perform, we are supposed to code for that. Okay, but when it comes to the data frame, it has got high level APIs where we have many inbuilt transformations and actions available, like reduce, your group by, and all that. And same goes with your data set as well. So that comes with even more refined APIs, and it works on your unstructured data as well, right? So like the data frame, you can even make use of it when you're using some kind of data, like the streaming data or stream of the text. Okay, then the next thing is your garbage collection. So when it comes to RDD, there is the overhead of garbage collection, and which ultimately results in creating and destroying of your Java objects, and that's a costly operations. Okay, but when it comes to data frame, like it is much optimized way of doing it, so it avoids the garbage collection, because we have got the catalyst optimizer here. So the garbage collection is avoided here. But when it comes to the data set, we have got the tungsten, and with the help of encoders, when we do the serialization and deserialization, it make use of the off-heap memory, which is your unsafe memory, and which is out of your JVM. So when it is out of JVM, there is no overhead of garbage collection on your JVM. So that's the reason you get the performance benefit there as well. So when it comes to the performance, your performance is good in RDD. Okay, it is good in RDD, and it is better in data frame. I mean to say that it is the performance better than RDD when it comes to data frame. But when it comes to the data set, you get the best performance. Okay, and reason being the aspects what I just discussed, that you get the compacted form, and with the help of the tungsten, it does a lot of optimization, and it even does the optimization to the hardware level as well, right? Okay, then it comes the lazy evaluation. So all the three are lazy. So lazy is nothing but the Spark, it doesn't evaluate your expression. Okay, so that means they do not compute their results right away. Instead, they just remember the transformation. So every time you create an RDD, it would be there in the memory, but the ultimately when you perform some action on it, it would be evaluated. So that's called the lazy evaluation. So it is there in all the three APIs. So, and the last is your programming language. So the RDD's APIs are available in Java, Scala, Python, and R. When it comes to data frame, you have got the APIs available in all the same as RDD, but the dataset APIs are available only in Java and Scala. So this is something which limits you to use dataset when it comes to Python and R. Okay, so let's yeah. So this was the comparison of all the three different kind of APIs, and I think you have got some clear idea, guys, like what all the aspects you need to consider when you're working with any of these three APIs. Okay, so next thing what I've done is I've just put small information which I've got at some place which says that when to use RDD. So it would give you some idea that okay, in which scenario you should use RDDs, and in which scenarios you need to make use of the data frames and data sets. So when it comes to RDDs, we use RDD when we need low level transformations, like even the map and reduce code you want to write on your own, and even the actions what you're performing, you want to have your own customized actions, right? So that's the time we use the low level I mean, we use the RDD. And also we use the RDD when we want to have more control on our data set. So as I just mentioned, we use low level APIs there. So you will have more control on your data, which is not the case in when it comes to the data set and data frames, because it already has a schema attached to it. So what you can max do is you can just make use of the columns or the fields what you get with the help of that schema. But here, with the help of those low level APIs, you can do much more with your data. And RDD also gives you the control over the placement of the partitions, which you don't get along with your data set and data frame. Okay, so when you need this control over placement of partitions, you should make use of the RDDs. Okay, so it gives you the partition data, and you can even control that as well. Next is the unstructured. When your data is unstructured, you should use RDD. And the ultimate or the last thing is the self optimization and the performance. When you are sure about that, you can do much better optimization and the performance. It all depends on the kind of use case you have. So if you are sure about it, you can make use of the RDD. Fine. Okay, so the next is when to use your data frames and data sets. So data frames and data sets are used when you don't want to use RDD. Okay, so okay, jokes apart, I just want to make sure that wanted to let you know that when you don't want to code in RDD, or you don't want to have that low level interaction with your data, probably you would prefer to use data frames and data sets. So in these scenarios, we make use of data set when you need high level abstraction and domain level domain specific APIs. So when I say that, it's like when you use Spark APIs, you need to probably you make use of mlib. You may have to use the combination of different libraries present. So these APIs are across are same across your different libraries. So which is something you get along with the data frame and data set. Okay, so and that gives you a high level of abstraction. Second thing is when you need high level expressions, when you want to have some filters, maps, aggregations, average, sum, SQL queries. So you don't want to literally code the aggregation logic. You don't want to literally compute the average. You just want to make use of the existing APIs. So that time you should make use of the data frames and data set, because or even when you want to use the lambda expressions. So that's the reason. That's the time you are supposed to use the data frames and the data set, because these APIs provides you the ready to use methods or APIs. Next is the higher degree of type safety. So when you need the type safety and compile time, at the compile time, and you want type JVM object, and you also want to take advantage of catalyst optimization and benefit of the tungsten, you are supposed to use the dataset, because dataset are the latest APIs and it gives you the best performance among or the best of the world of both RDD and data frame. So that when you need the best, you are supposed to use the best, and that's the data set. And ultimate thing is the unification and the simplification of API across Spark libraries. So as I just mentioned, when you need this unification, because when you are kind of switching back and forth, using different libraries from mlibs, from Spark SQL, or from GraphX, and you want to use probably somewhere you want to use Python, somewhere you want to use Scala. You get that benefit here when it comes to data frame and data set, because the usage and the APIs are almost same in that. Okay, so yeah, that's all, guys. I think you'll have some fair idea of the difference between RDDs and data frames and data set. So thank you so much for watching this video, and definitely I would like to know your views about it. And please don't forget to comment and hit the like button in case you like this video. Fine. Okay, guys. Bye bye.